Okay, today's lesson is 16.6, writing scientific notation. Now that you know how to read scientific notation, writing scientific notation is probably going to be pretty simple. There really is only two key steps that you really need to pay attention to when writing scientific notation. Step one, you need to move the decimal point so it's located to the right of, and then they have the leading non-zero digit. You're probably, what does that mean? So what I would say is you move the decimal point so it's located to the right of the first digit. Okay, so that you have a number point, a number between 1 and um, 10 as your first digit, as your first number in your scientific notation. Because essentially what you're doing, I can't write here, can't write and talk at the same time. What you're doing is you are, there we go. What you're doing is you are creating and working backwards to create that scientific notation. And we're going to practice that a little bit so you can see what that looks like. Then, excuse me, you need to, step two is to count the number of places you moved the decimal point, and that indicates the exponent of the power of 10. Okay? And that's essentially what you're going to do. I want to note, if you look over here at the study tip, this is interesting. When you write a number greater than or equal to 1 and less than 10 in scientific notation, the 0 is the exponent. So if you're looking to write the value for just the number 6, it would be 6 times 10 to the 0 power, because 10 to the 0 power equals 1. So 6 times 1 is 6. So I thought that that was somewhat interesting. And you may come across that. It's not very common, but you may come across that. Okay, so if you jump down here to example one has says that Google purchased YouTube for $1,650,000,000. They want you to write that in scientific notation. So you find, this is the key here, you find right here the number. Now the number, if it's all zeros after where the last digit is, then you don't write down those zeros. You cut it off right there. Okay, so it'd be 1.65. The whole idea of scientific notation is to shortcut your method. So you don't want to have to write all those zeros. Okay, and then once you've done that, so you moved your decimal from the end all the way to here, you count the number of times you moved it, and it becomes times 10 to that power. So it'd be times 10 to the ninth power. Now, let's just say that it was 1.650 and then there's a 1 here. You would include that 0. Okay, this 0 would get included because you stop after you have the last digit between 1 and 10. Okay, so 1 through 9. And then if there's a digit that's 0, or if there's a digit that's, there's not going to be a digit that's larger than 9, then you wouldn't include that. Okay, so just drop those zeros. Make sure you drop those zeros. That's probably the error that most kids make, is they forget to drop the zeros, and then they end up writing 1.65, and then they write the zeros in 0, 0, 0, 0, 0, and what's the point of doing that? Then you might as well write the number out. The whole point is to make it easier for you to read. So that's essentially what you're going to do. And it really is not, it is not difficult. Okay, so if you look at the examples here, this is an example now of a negative exponent, where you would have a negative exponent. So if I have this number, which is, I could read it, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. So it's 268 millionths. Okay, so when you have that number, you're going to look for, again, the first digit. So right there it is. The first time all those zeros in front are going to disappear. And the 2 is the number you're looking for. And you're going to move that decimal after that, from here all the way to there. Okay, so when we do that, you're going to notice that it becomes 2.68 times 10. Now you count your decimal point places, but because you're using a number that is smaller than 1, it becomes a negative exponent, so it's the negative 6th power. You move it 6 spots, but it's going in the opposite direction, so it's the negative 6th power. It's really how you do it. It's really quite simple. Okay, and again, you drop those zeros. All right, so what I would like you to do is pause your computer, and I would like you to do number 1, and I would like you to do number 5. 1 and 5, and pause your computer, then come back. Okay, number 1. Number 1 is 50,000, so again, you look for that decimal place, so it becomes 5, and you can put 0.0 if you want, or you can just put 5. Okay, it's fine to put either one. All right, so it's 5 times 10. Now you got to count your spots. So you have 1, 2, 3, 4. So it's 10 to the 4th power. And that's all you do. That's number 1. Number 5, you are going to do the same thing, except that you're going to move your decimal down here. Okay, so it becomes 3.3 times 10, and then you count. So you have 1, 2, 3, 4, 5, 6, 7. So it becomes 3.3 times 10 to the negative 7th power. Don't forget that negative, because 3.3 to the 7th is very different than 3.3 to the negative 7th. Okay, if you write to the 7th, it would be wrong. So that's how you do it. Not too difficult. Okay, then you can use scientific notation. So this is an example of a real life situation where you would probably use it, and you're going to do a little math involved in using it. Okay, so you have to do both. So if you look at example 3, it says the album has sold, let's see, 8,780,000 copies. How many more copies does it need to sell to receive the award? And down here it tells you what they need to sell the award. Okay, so you have to do a little subtraction first. You have to take this number, 10 million, I don't know, 1, 2, 1, 2, 3, 1, 2, I'm missing a 0, 3. And then you're going to subtract from that the 8,780,000. And you're going to get an answer of 1,220,000. And then you're going to write this answer in scientific notation. So the first digit is a 1, so it's 1.22. You drop those zeros times 10, and then you just count. 1, 2, 3, 4, 5, 6 to the 6th power. And that's your answer. And your label would be copies. That's how many more they would have to sell. Okay? And make sure you label it, because it is a word problem. Okay, then number 4, example 4 talks about real life and applying it to real life, and then with comparing and comparing different values. And they give you a little short, one way to do it, and I'm going to be honest with you, this is probably the way that I would do it. Even if I did it the shortcut method, I probably would check it with this other method. You could work them out. You know, you could work out all of these values. That's an option. You could work them all out and then figure it out, which one's greater than or less than or equal to. Or you can do this step-by-step method that they have listed here. You can, step 1, compare just the powers of 10. And that should help you, because if you have a 10 to the 7th and a 10 to the 8th, 10 to the 7th is going to be smaller than a 10 to the 8th. Because that 10 to the 8th has an extra value, an extra place value. So that's one way of doing it. And then you could also, when the powers of 10 are the same, you can compare the factors. So 2.51 is less than 5.42. Okay? So because they're both 10 to the 2nd power, you're going to end up with 2.51 being smaller than 5.42. And that's how you can do that too. Now, again, I know myself, and I know that I probably would check it by working them all out because that's just how I am. You don't have to do that, but that's a way to ensure that you're doing it correctly. Okay, so what I would like you to do now is I'd like you to pause your computer and I want you to do number 7. Pause your computer and do number 7. Okay, so number 7 says, in example 3, an album has sold 955,000 copies. How many more copies does it need to sell to receive the award? Write your answer in scientific notation. So you have to do a little subtraction. You have to go back to this value right here, okay, 10 million, and you need to subtract from that, oops, where am I? There we go, 10 million, and you need to subtract from that 955,000. And when you do that, look at my book here. When you do that, you're going to get an answer of there we go, 9,045,000. So you have to then write this number in scientific notation. So it'd be 9.045 times 10, and then you count 1, 2, 3, 4, 5, 6 to the 6th power. And then your label would be copies. Okay? Okay. If you understand these sample problems, then you can move on. If not, you really need to rewatch your video and make sure you're writing these in your notes. Okay, so for your practice problems, and I cannot remember what I'm doing this at home early in the morning, and I can't remember what my lesson plan said. So I'm going to have you do, I would rather you do, I think I'm going to have you do what I'm telling you to do now. So if it on the board it says something different, do this. I would like you to do number 3. I would like you to do number 5. And I would like you to do number 15. 3, 5, and 15. Okay? For tomorrow. Okay?